Here's one last example of the same method being applied to a cubic equation instead of a quadratic. To give you an idea that when we say polynomial inequality, we really mean that this method can be applied to any polynomial. Okay, first step is obviously bring all the terms on one side. Now, remember the goal is to factor it, so you have to go back to what we learned 3 weeks ago. Different methods of factoring. The first thing you want to try is looking at the greatest common factors. So in this case, you can kind of see that x plus 1 is a common factor, which gives you x squared minus 4 times x plus 1 less than equal to 0. But then you also know x squared minus 4 can be factored further using difference of squares as x minus 2, x plus 2, x plus 1 less than equal to 0. Now following the steps, first you're going to set this equal to 0 and find the endpoints. So you get x is 2, x is negative 1, and x is negative 2. Next step is you plot these on the number line, negative 2, negative 1, 2. Now because there are 3 solutions, now there are how many? 1, 2, 3, 4 regions. To the left of negative 2, between negative 2, negative 1, between negative 1, 2, and then to the right of 2. Now let's pick test points. Test points. We're going to have to pick 1, 2, 3, 4 test points. The convenient one here is 0, so I'll pick that. Let's say I pick negative 1.5 here, I pick negative 3 here, and I pick 3 here. Now let's plug these into our equation. Starting with negative 3, let me plug it into the factored form because that's going to be easier. Negative 3 plus 2, negative 3 plus 1. Let's see, that's a negative number, that's a negative number, that's a negative number. You multiply negative, 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 you end up with negative. F of negative 1.5, that's negative 1.5 minus 2, negative 1.5 plus 2, negative 1.5 plus 1. Again, you don't have to evaluate the actual value because all you care about is its sign. That's negative, that's a positive, and that's a negative. A negative times positive times a negative is positive. F of 0 is going to be negative 2 to 1. Now that's negative, positive, positive, which is a negative. And lastly, f of 3 is going to be 1, 5, 4, all positive. So this is positive, which means redrawing, these are my points and my signs are negative, positive, negative, positive. But I'm interested in when it is negative, that's going to be this region including negative 2, this region including the endpoints. So x belongs to negative infinity to negative 2 included, union negative 1 to 2, all endpoints included because there's an equality in there. So this method works not just for quadratic but for any degree equation.